Hello everyone. Today we are starting with class 9th maths curriculum. We are already having videos for all the chapters of class 10th maths curriculum. So today we are starting with the chapter number 1 of class 9th, that is number system. First of all, what is number system? Number system is also known as numeral system, and it is a system of naming and representing numbers. So by this system we are representing the numbers, we are naming the numbers. And in maths there are so many types of number systems are there, like your binary number system is there, your decimal number systems are there. So all these are the type of number system for representing the numbers and for naming the numbers. Then what numbers are? We all know that numbers are mathematical values used for counting, used for labeling, used for representing your any of the things, objects, and they are used for performing arithmetical calculations. Whatsoever the calculations we are doing doing it using numbers only. There are various types of numbers are there. We have learned all these numbers in our previous classes. Like natural numbers we have learned about whole numbers, we have learned about integers. Now in class 9th we'll be knowing about rational numbers, irrational numbers also. So what all these numbers are, just recall it once. Natural numbers. Whenever we are talking about numbers starting from 1 goes till end, that means till infinite, all these counting numbers are your natural numbers. Natural numbers are represented by capital N, and all the numbers, set of all the numbers starting from 1 goes till whatsoever number comes in our mind, that means till infinite, whatsoever number comes in our mind, all are group of your natural numbers, that is collection of natural numbers. Then comes your whole numbers. When we are taking all the natural numbers, including this, along with this, when we are taking 0 also, then it becomes a group of your whole numbers. And whole numbers are represented by capital W. That means all the natural numbers and 0. If we will take all these numbers together, then it becomes a collection of, or the set of your whole numbers. Then comes your integers. Integers are represented by Z. From where Z has come? Z has come from a German word, that is zählen, which means to count. When we are taking all the whole numbers and the negative natural numbers also, that means if we will take say -3, -2, -1, 0, 1, 2, 3, all these numbers, that means in the positive direction also till infinite, and in the negative direction also till infinite. If we will take all these numbers, the group of all these numbers or the collection of all these numbers is known as integers. All these numbers we have already learned in our previous classes. Now how to represent all these numbers on the number line, that even we have already learned. So what number line is? A straight line we are taking. In the center we are taking 0. In the right hand side we are taking the positive numbers 1, 2, 3 at the equal distance. Unit distance we are taking, and at the unit distance we are numbering all these numbers. In the left hand side we are taking the negative numbers like this, -1, -2, -3, -4. If we will go towards the left hand side of any number, the value of the number will be less than the given number. And if we are going towards the right of any given number, the value of the number will be greater than the given number. Like suppose if I am talking about, if we are considering 2, if we will take a point, say 5, so 5 is towards the right of this 2, that means the value of 5 will be greater than the value of 2. If we will take a number, say -1, so this -1 is towards the left of this 2, that means value of -1 will be less than this 2. So this is how we know how to represent all these numbers. Like if we have to represent 5, so this is the number which we have to represent, and on this number line this will be the point. Suppose we are representing it by capital A, so this will be the point which is representing your 5. If we have to represent 0, so this is the point which is representing 0. It could be given any name, suppose it is B. So this is the point which is representing your B, and its value is equivalent to your 0. Similarly, we can take any number, say -4 also. So this is suppose C. So this C point represents -4. So all these, your natural numbers, your whole numbers, your integers, can be represented very easily on the number line. The distance between every two consecutive numbers is equal. That means distance between 0 to 1, if it is your unit distance, so distance between 1 and 2 will even be the unit distance. Similarly, between 2 and 3, so on. Whether we go towards the right or we go towards the left, the distance between these numbers is equal. Whensoever we are going towards the right, the value of the number is increasing. Whenever we are going towards the left, its value is decreasing. This is how we can represent all these numbers. Now from here we can conclude even that all the natural numbers, all these natural numbers are part of your whole numbers. That means all natural numbers are your whole numbers. All natural numbers are your integers also. But all whole numbers are not natural number, because 0 is even a whole number. It is a whole number, but it is not a natural number. Similarly, all the whole numbers are your integers, because 0, 1, 2, 3, all these are part of your integers also, but all the integers are not natural numbers, nor it is your whole numbers. So we can easily conclude from all these things that natural numbers, all the natural numbers, all the whole numbers are your integers, but all the integers are not natural numbers and not your whole numbers. Now we'll be discussing what rational numbers are, what irrational numbers are. Hope it is clear to you what natural numbers are, what whole numbers are, what integers are. We'll be discussing now what rational numbers are and what irrational numbers are. Now let's see what is rational numbers. Rational numbers has come from the word ratio. From here, the ratio, the name has come, that is rational number. Rational numbers are denoted by capital Q, and Q denotes over here quotient. So all the numbers which can be represented in the form of P upon Q, where denominator Q is not equivalent to 0 and P and Q are any integers, such type of numbers are known as rational numbers. So all the numbers which can be represented in the form of P upon Q, where denominator Q should not be equivalent to 0 and P and Q could be any of the integers, all such type of numbers are known as rational numbers. Like example, we can take 2 upon 3. Over here, 2 is P and 3 is your Q, and both the 2 and 3 are your integers, and this your Q, that is 3, is not equivalent to 0. So it is a rational number. Similarly, we can say 0 is even a rational number, because 0 could be written as 0 upon 1 also. Over here, P is 0 and Q is your 1. And Q is not equivalent to 0, and 0 and 1 both are your integers. So 0 is even a rational number. Similarly, if we are going to say, so minus of 5 is even a rational number. Minus of 5 could be written as minus of 5 over 1. So similarly over here, we can see that P and Q both are your integers and Q is not equivalent to 0. So all these type of numbers are your rational numbers, which can be represented in the form of P upon Q, where P and Q could be any of the integer, but Q should not be equivalent to 0. From here we can say that all the natural numbers, all the whole numbers, all the integers are your rational numbers. All comes under the category of rational numbers, but all the rational numbers are not your natural numbers, are not whole numbers, and not your integers also. So we can easily conclude from here all natural numbers, because natural numbers are your 1, 2, 3 for all these numbers. Whole numbers are starting from 0, 1, 2, 3, all these numbers, and your integers are negative and positive numbers, minus 3, minus 2, minus 1, 0, 1, 2, 3. All these numbers are part of your rational number. So all these are your rational number, but all the rational numbers, because 2 upon 3 is a rational number, but it is neither natural number nor your whole number, or nor your it is your integer also. So that's the reason all the rational numbers are not natural, not your whole, and not your integers. Now what equivalent rational numbers are? See, rational numbers are not unique. Like if I am talking about 2 upon 3. So 2 upon 3, if I am saying, so 2 upon 3 is equivalent to your 4 upon 6 also. If I am going to multiply this 2 by 2, and 3 by also 2. So 2 multiplied by 2 will become 4 and 3 multiplied by 2 will become 6. And the value of 4 upon 6 is also your 2 upon 3 only. Similarly, I can write 2 upon 3 as your 2 multiplied by 3 will be your 6 and 3 multiplied by 3 will be your 9. So value of 6 upon 9 is also 2 upon 3. So we cannot write a rational number. It is not the unique representation. We can write 2 upon 3 as 4 upon 6 also. We can write 2 upon 3 as 6 upon 9 also. We can write 2 upon 3 as 4 2s are 8, 4 3s are 12 also. So all these are the representation for 2 upon 3 only. So all these representations whose value is same, all these are known as your equivalent rational numbers. Because if we are going to simplify it, all of these values will be 2 upon 3 only. So all these are your equivalent rational numbers. Representation of 2 upon 3 only. But whenever we have to represent all these numbers on the number line, we always represent the simplified form only. If we have to represent 4 upon 6 also, in that case also we will represent 2 upon 3 only. If we have to represent 6 upon 9, in that case also we will be representing 2 upon 3 only. The simplified form or the simplified form of your any of the rational number, we will be representing on the number line. So what over here we conclude over here is that your P and Q, the value of P and Q, whenever we are representing on the number line, the value of P and Q, it should be your co-prime. These numbers should be a co-prime. They should not have a common factor except 1. They should have only one common factor, that should be 1 only, and this means your 2 and 3 value of P and Q should be your co-prime numbers. For representing on any of the number line, P and Q should be your co-prime numbers. It is simplified. That means number should be in the simplified form. Then only we are representing it on the number line. Now, how to find the rational number between given two rational numbers? If any two rational numbers are given to us, and between these two rational numbers, we have to find, say, 1 rational number or 2 rational number or 5 rational number or 10 rational number. So, how we can find it out? So, suppose we are taking any two rational number. One of the rational number is x and another rational number is y. And value of x is less than your y. That means any of the rational number will be coming between these two only. The value of that rational number will be greater than your x and will be less than your y. So, sum of these two rational numbers divided by 2. This will be the rational number which will lie between x and y. If there are any two rational numbers, say one of the number is x, another number is your y. So, any rational number which will lie between x and y will be your x plus y upon 2. Suppose I am taking, say, I have to find a rational number between 3 and 4. So just now over here what we have said is x is less than y. That means we are over here value of x is your 3 and value of y is your 4. So any rational number which will lie between these 3 and 4 will be x plus y by 2. That means 3 plus 4 by 2. That means 7 by 2 will be the number which will lie between 3 and 4. This is how we can find if we have to find any one rational number. Say over here, suppose I am representing it like this. This is your 3, this is your 4. Now we are saying that 7 by 2 will lie between these two numbers. So suppose over here, this is your 7 by 2. Now if we have to find three rational numbers between 3 and 4. If we have to find one only, so this is a number which is your exactly between 3 and 4. Now suppose we need to find more rational numbers. What we could do is, over here 3 is a number and 7 by 2 is one of the number. The number which will lie exactly between these two will be somewhere here, and this, suppose this is your A, this is your B and this is your C. And over here one more point will come, that is suppose your D and this is suppose your E. Now the point B, what will be the value for point B? B will be E plus A by 2, that means it will be 3 plus 7 by 2. Sum of these two numbers divided by 2. This will be the value of B, and this point B will lie exactly between 3 and 7 by 2. We can calculate it even. For the numerator part, 2 will be the LCM. 3 multiplied by 2 will be 6 plus 7. This is a numerator divided by 2. This is your denominator. So 6 plus 7 will become 13. This 2 will come in the denominator. So it will be a 13 by 4. So this 13 by 4 will lie between 3 and 7 by 2. And it is also in between 3 and 4 also. So this is the point which will exactly lie between 3 and 7 by 2. Similarly, we can find the value of D also. It is the midpoint of your A and C. Exactly, it will lie between A and C. What the value of D will be? D will be your 7 by 2 plus this is your 4 by 2. Sum of these two values divided by 2 will give you the value for D. This is how we can find as many numbers between any two given numbers as much we have to find it out. Similarly, there could be many more methods. Even this is first of the method. Now another method could be, suppose your two consecutive numbers are given. Suppose I am saying 5 and 6 is given to us. And we have to find, suppose 5 rational numbers between these two given numbers. So what we could do is, 5 rational number we have to find. What is the next number to it? If we are going to add 1 in 5, we will be getting 6. That means we want denominator as 6. Now for getting denominator of 5 as 6, what we can do is, we can multiply it by 6 and divide it by 6. Equivalent rational numbers, 5 could even be written as 5 6 are 30 upon 6. 5 could even be written as 5 multiplied by 6 over 6, that is 30 over 6. Similarly, 6 could be written as 6 multiplied by 6 over 6, that is 36 over 6. So 5 could be written as 30 over 6. 6 could be written as 36 over 6. Now 5 numbers between these two numbers will be 31 over 6, 32 over 6, 33 over 6, 34 over 6 and 35 over 6. This could be your one of the method. One of the method we have seen just now. This is another method of finding as many rational numbers between two given numbers as we want. Similarly, one more method could be their easiest method. Suppose we have to find, see, over here we had taken multiplied by 6 because 5 numbers were required. So we have taken just the next number, that is 6, for getting 5 numbers. But if although over here your numbers were very small, like 5 and 6 were the number, so calculation was very easy. But suppose big numbers are there. Say I am saying 27 and 28 are the numbers. It could be or bigger numbers also. So what we could do is, we can simply multiply and divide it by 10. So that our calculation will become easy. So what we could write, 27 could be written as 27 multiplied by 10 divided by 10. That is your 270 over 10. Similarly, 28 could be written as 28 multiplied by 10 divided by 10. That is 280 over 10. Now we can find 9 rational numbers between these two given numbers, and the numbers will be 271 over 10, 272 over 10, 273 over 10. Similarly, we can find many more numbers between these two given numbers. Instead of multiplying it by 10, we could have multiplied it by 100 also. We could multiply it by 1000 also. So by whatsoever number we want, we can multiply and divide it, because these are your equivalent rational numbers only. Because 27 could be written as 270 over 10. These are your equivalent rational number. So we can find as many rational numbers between any two given numbers as we want. So we can say that between any two given rational numbers, there are infinitely rational numbers which lie between any two given rational numbers. All these are the methods, any of the method we want to use, we can use for finding rational number between any two given numbers. Now let's see what is irrational numbers. The numbers which are not rational are known as irrational numbers. That means numbers which cannot be represented in the form of P upon Q, where Q is not equivalent to 0 and P and Q are any integers. Such numbers are known as your irrational numbers. Irrational numbers are also represented by capital P, or it could even be represented by capital R minus capital Q. Why it is represented by capital R minus Q, that we'll be learning just now only. So whatsoever the numbers are not rational numbers are your irrational numbers. That means all the numbers which cannot be represented in the form of P upon Q, where Q is not equivalent to 0 and P and Q are any integers, all such numbers are known as your irrational numbers. So what all the examples of irrational numbers are? We can take it as root of 3, 2, root of 2, root of 3, pi could be example, root of 5 could be any of the example for irrational numbers. So all these are your irrational numbers. Along with that, we can take 0.01, 001, 0001. All these are your examples of irrational numbers. So what real numbers are? Now when we are saying that all these numbers which can be represented in the form of p upon q, where q is not equivalent to 0 and p and q are integers, are your rational numbers. And all those numbers which cannot be represented in the form of rational numbers are your irrational numbers. That means whatsoever number comes in our mind, whatsoever number is possible, if we are going to take all together, it becomes a group of your real numbers. Real numbers are represented by capital R. That means real number are the group of numbers, whatsoever number comes in our mind is coming under the category of real numbers. So what real numbers are? Real numbers are your group of your all the rational numbers. If we take all the rational numbers and all the irrational number, we will be taking all the rational and all the irrational number, then it is making a group of your real numbers. So whatsoever number is possible, all numbers comes under the category of real number. So number will either be rational or irrational, and if we are taking all rational and all irrational number together, it is making a group of real number. That simply means if we are going to take a number line, suppose this is your number line, we had just discussed that it is in the center we are taking 0, then at equal distance we are taking numbers like this. We are taking negative numbers in the left hand side. So whatsoever number comes in between 0 and 1, it could be your rational number even, it could be irrational number even. Suppose I am saying 1 by 2. So this will be the point which is your 1 by 2. Now in between 1 by 2 even there will be so many points will be there. So all these points which will be rational will be coming on this number line. Similarly root of 2, that is your 1.414 something, but it is an irrational number. It will be somewhere here suppose. So this is your suppose root of 2. So whenever we are representing a number line, all the points on the number line will be a unique real number. If I am talking about this point, it will be represented by any of the real number. If I am talking about this point, this will even be represented by any of the real number. That means on the number line, every point is representing a real number. Or we can say, if we are talking about any of the real number, so any of the real number is represented on the number line by a unique point. For every real number, we are having a unique point on the number line. That simply means on the number line, every point on the number line is representing a real number, and every real number can be represented by a unique point on the number line. So all the numbers, whatsoever number comes in our mind comes under the category of real number. There is no number which is not coming under the category of real number. Every possible number is coming under the category of real number. Now how to represent this irrational numbers and the rational number on the number line? So we have already learned how to represent rational number on the number line. Suppose I am taking an example, say 3 upon 4. 3 upon 4 I am to represent on the number line. So over here, I can see over here that this number, if I am going to represent it in the form of decimal, this will be less than 1. That means this point will lie between 0 and 1. Over here, we can see the denominator is your 4. If denominator is 4, that simply means we have to divide 0 and 1 into 4 equal parts. I am just removing this 1 upon 2 from here. This 0 and 1, between 0 and 1, your 3 upon 4 will lie. Now, if I am to divide this 0 to 1 into 4 equal parts, because denominator over here is 4, so suppose this is the first part, second part, third part and fourth part. This is from here to here, here to here, here to here, here to here. That simply means between 0 and 1, I have divided it into 4 equal parts. So first part will be 1 upon 4. Second part will be 2 upon 4. Third part will be 3 upon 4. And this is the point which is to be represented. Similarly, if I am to represent say 7 upon 4. So I know that 7 upon 4 value, if I am going to represent it in the form of decimal, it will be 1 point something. That simply means this 7 upon 4 will lie between 1 and 2. And again the denominator is 4 only. That simply means we have to divide 1 and 2 into 4 equal parts. Just I am removing this from here. So again I am to divide it 1 and 2 into 4 equal parts. So 1 part, 2 part, 3 part and 4 parts. Now this 1 could even be written as 4 upon 4. 4 upon 4 is 1 only. So this 1 is 4 upon 4. The next point will be your 5 upon 4. The next will be your 6 upon 4. Then this point will be your 7 upon 4. And this is the point which is to be represented. So this is how we can represent any of the rational number on the number line. Now, if I am to represent say root of 2 on the number line, how I will be representing? So see, for representing irrational number on the number line, what we could do is, suppose this is your 0, this is your 1. We know the Pythagoras theorem. In a right angle triangle, if there is a right angle triangle, and suppose this is your A, this is your B, this is your C, the side opposite to 90 degrees is hypotenuse. Suppose this is your base, this is your perpendicular, and this is your hypotenuse. In that case, hypotenuse is square. It is equivalent to base is square plus perpendicular is square. This is your Pythagoras theorem. We already know about it. So suppose from here I am taking unit distance. 0 to 1 is a unit distance. At point 1, I am going to draw a perpendicular. Suppose at this point we have drawn a perpendicular. This is the perpendicular and I have taken the unit distance only. This is unit distance. This is your 1 unit. 1 unit it is, and similarly the same 1 unit I am taking from here to here. Suppose this is your O point, this is your A point, and this is your B point. This is even a unit distance I have taken. Now what this hypotenuse will be? This is perpendicular. I have drawn a perpendicular. That means this angle will be on 90 degree. And if this is unit distance, OA is unit distance and OB is even unit distance. That means your base is 1, perpendicular is even 1. So it is 1 square plus 1 square. That is 1 plus 1. That means hypotenuse square will be your 2, or hypotenuse will be root of 2. Here we are considering only the positive value. So hypotenuse, that means OB. OB will be your root of 2. Now if I am going to take O as the center and OB as the radius. O as the center I have taken and OB as we have taken as the radius. If I am going to draw the arc and it is going to touch the number line, suppose from here I have taken this as the center, this as the radius, I am going to draw the arc. It is going to touch the number line at this point C. Then this C point will represent root of 2. Because this OC is equivalent to your OB only. Because we had taken O as the center and OB as the radius. So OB will be equivalent to your OC and OB is root of 2. So OC will even be root of 2. This is how we can represent root of 2 on the number line. Now suppose I am to represent root of 3 on the number line, then what I will do? So see over here, if this is your root of 2, OB is your root of 2. Now if at point B I am going to draw the perpendicular. This is the perpendicular. Suppose this is your point D and this DB is your unit distance only. It is even your unit distance. Then what the value of OD will be? Again over here this is your 90 degree. Over here we have taken B as the 90 degree. Now OB is root of 2. BD is 1. We have to find the value of OD over here. So OD is square. This is your hypotenuse square. It is equivalent to OB square, that is your base square, plus perpendicular is your BD square. OB is root of 2. Root of 2 square. BD is your 1. 1 square. Root of 2 square will be 2 and 1 square will be 1. That is your OD square. OD square is your 3. So what the value of OD will be? OD will be your root of 3. That simply means this OD is your root of 3. Now if I am going to take O as the center and OD as the radius. O as the center and OD as the radius, and I am going to draw the arc which is going to intersect the number line at suppose the point E. Then E will represent root of 3. This is how we can represent root of 2, root of 3, all these numbers on the number line. Hope it is clear how to represent the rational numbers on the number line, how to represent all these irrational numbers on the number line. what we have done is, first of all, we have drawn root of 2. We have simply used the concept of Pythagoras theorem. Now, once we are having the value of root of 2, if I am going to draw perpendicular at point B of unit distance, in that case, this is your root of 2, this is your 1, and this OD will be your root of 3. Because from here, O we have taken as a center and OD as a radius. That means OD will be equivalent to your OE also, because O is the center, OD is the radius. We have taken this and drawn an arc on the number line which is going to intersect the number line at point E. So OE will be equivalent to OD, that is your root of 3. This is how we can represent it on the number line. Till now we have seen that the set of all the possible numbers is known as your real numbers, and real numbers are composed of either your rational numbers or your irrational numbers. That simply means all the possible numbers are your real numbers, and real numbers are either your rational numbers or it is your irrational number. When we join these two, we are getting a set of your real numbers. Real numbers are represented by capital R. Rational numbers are represented by capital Q, and irrational numbers are either represented by capital P or it can even be represented as capital R minus Q. That means from the set of real numbers, if we will remove the set of rational numbers, then whatsoever the numbers are remaining will be the set of your irrational numbers. From the set of real numbers, if we will remove the set of your rational numbers, the remaining numbers will be your set of irrational number. That's the reason irrational numbers are even represented as R minus Q. Now let's see how to represent real numbers in terms of your decimals. Now real numbers are either your rational numbers or your irrational numbers. First we are taking the case of your rational numbers. So we know that the numbers which can be represented in the form of P upon Q, where Q is not equivalent to 0 and P and Q are any integers, such type of numbers are known as your rational numbers. So when any of the number is in the form of P upon Q, we can simply divide it and we can find its decimal representation. Like if I am going to take an example, 1 upon 2. 1 upon 2 is in the form of P upon Q, where P is 1 and Q is your 2. Similarly, 1 upon 3 is even in the form of P upon Q. That means all these are your rational numbers. Number could be your 2 upon 3 also. It could be your 2 upon 5 also. It could be 1 upon 7 also. All these are in the form of P upon Q, and all these numbers are your rational numbers. If we will be dividing these over here, 1 by 7, in this 1 is your dividend and 7 is your divisor. Over here 1 is your dividend and 2 is your divisor. So when we will be dividing all these numbers, we can represent it in the form of your decimals. So whensoever we will be representing any rational number in terms of decimal, there will be two types of cases will be there. The case one case will be when your remainder will come to 0. That means after certain steps of division, your remainder will become 0. Your division will be terminating. In that case, in such type of cases, these type of representations are known as your terminating type of decimal representation. Suppose I am going to take an example of 1 upon 2 over here. So if I am going to divide 1 and 2, over here decimal will come initially, 0 will be here, 2, 5 is 10. That means 1 upon 2 could be written as 0.5. What is the case over here? That after one step, your remainder has come to 0 or it has terminated, and your representation 1 upon 2 could be represented as 0.5. Similarly, if I am going to take an example of 2 upon 5 over here. So 2 is the dividend over here, 5 is the divisor, decimal will come initially, 0 will come here, 5, 4 is 20. That simply means your 2 upon 5 could be written as 0.4. So all these type of rational numbers which terminates after certain steps are known as your terminating type of decimal representation. So whenever we are going to take any example of rational number, either two type of cases will be formed. Either your division will terminate after certain steps, or the second case will be when your division is not going to terminate. After as many steps you want to go, you can continue, but your remainder will never ever come to 0. Like if I'm going to take an example of 1 upon 3. So in the case of 1 upon 3, here initially decimal will come 0 I have taken, 3 3s are 9, again 1 is the remainder, again 3 3s are 9, again 1 is the remainder, again 3 3s are 9, 1 is the remainder. So what we can see over here, your remainder is again and again coming the same, and because of that your number is repeating again and again. In the case of question, your number is repeating again and again. So two types of cases are there when your remainder will come to an end, and the second condition is when your remainder will never ever come to an end. So first condition, when your remainder is coming to an end, these type of decimal representations are known as terminating type of decimal representation. And the second case is when your remainder will never ever come to an end, either a number or a group of number is going to repeat again and again. These type of decimal representations are known as non-terminating, reoccurring or repeating type of decimal representation. So whensoever we will take any rational number and we are going to divide it and we will convert it into the terms of your decimal representation, two cases will be there. Either after certain steps your remainder will come to an end, your remainder will become 0, it is going to terminate. Such type of decimal representations are known as terminating type of decimal representation. And the second case is your sum of the remainder, any of the remainder is going to repeat again and again, or any of the number or the group of number is going to repeat again and again. In such type of cases, it is your non-terminating reoccurring decimal representation. So if I am going to represent this, it will be represented as 1 upon 3 could be written as 0.3 bar. Bar simply means 3 is going to repeat again and again. If I am going to take an example, say 1 upon 7. In this case, 7 is your divisor. 1, 0.0 I will take over here. 7 1 is 7. 10 minus 7 is 3. 0 I will take. 7 4 is 28. 2 0. 7 2s are 14. 6 7 7 7 8 is 56. 56 4 0. 7 5s are 35. 5 0. 7 7s are 49, then again 1. See over here, initially it was 1, now 1 has repeated again. So again the same number are going to repeat. I'll take 0. So 7 1 is 7. Then again over here 3, 0. 7 4 is 28. That simply means these numbers are going to repeat again and again. That simply means if we are going to divide it, it will be your 0.142857 bar. That means this group is going to repeat again and again. After this, again 142857 will come. After that, again 142857 will come. Because this group as a whole is repeating again and again, that's the reason bar will be on this number. Whatsoever number is repeating again and again, bar will be applied on that. So this is how we can represent any rational number in terms of your decimal. So what we can conclude is, whenever we are dividing a rational number, in its decimal representation, two cases will be there. Either after certain steps, your remainder will come to an end, it is going to terminate. In such type of cases, it is known as terminating decimal representation. And in this, there is no dot dot dots are there. It simply means 0.4 means, it simply means your division has come to an end. This is the decimal representation. This is the decimal representation of 1 upon 2. This is the decimal representation of 2 upon 5. So these type of cases are your terminating decimal representation. And the second case is when after as many steps you want to go, if you are going to continue your division, but after as many steps you want to continue, your remainder will never ever come to an end. It will never come to 0. Either a number or a group of number is going to repeat again and again, and such type of decimal representations are known as non-terminating reoccurring decimal representation. Over here we can see the number of digits which are repeating will be less than the divisor. Here your divisor, in the case of 1 upon 3, your divisor was 3. That simply means over here only one number was repeating. That means number of the digits which are repeating will be less than the divisor. In the case of 1 upon 7, 7 is the divisor, and number of digits which are repeating is 1, 2, 3, 4, 5, 6. 6 digits are repeating. That simply means we can conclude that the number of digits which are repeating will be less than the divisor. So this is the decimal representation for the rational number. But when we are taking the irrational number, so irrational number, just now we had discussed that irrational numbers are the numbers which cannot be represented in the form of P upon Q. The numbers which cannot be represented in the form of P upon Q, where Q is not equivalent to 0, and your P and Q both are your integers. So the decimal representation of irrational numbers is non-terminating, non-repeating. Non-repeating we can say, non-reoccurring we can say. Decimal representation is a decimal representation of your irrational number. For irrational numbers, decimal representation will be non-terminating, non-reoccurring or non-repeating. That simply means it is never ever going to come to an end, because it cannot be represented in the form of P upon Q. So we are not going to divide it. But if the number is like I am saying 0.0100100001, like dot, that simply means your division has not come to an end, and there is no number, not a pattern is there which is going to repeat again and again. Over here 01, 001, 0001. So there is not like 01 is repeating again and again. It is not like that. So these type of decimal representation, which is non-terminating, non-repeating type of decimal representation, are the representation for your irrational number. So whenever we are going to see any decimal representation, simply by seeing only we can come to know that it is a rational number or it is an irrational number. Like if we are going to take an example, say I am saying 0.5732. So over here we can see, over here dots are not there, bar is even not there. That simply means this is your terminating type of decimal representation, because it has terminated, remainder has come to an end. So it is a rational number. If your number is like 0.535353 ... Here we can see that 53 is repeating again and again. So it is your non-terminating, because dot is there, that means it has not terminated. So non-terminating, repeating type of decimal representation, and it is a case of your rational number, because either it is your terminating or it is non-terminating repeating, both are your rational number type of representation. Now if I am going to take an example, 0.23758437893 ... Over here we can see that there is not even a single group which is repeating again and again. So these type of decimal representation which has not terminated even, and none of the group is repeating again and again, such type of decimal representation are non-terminating, non-repeating type of decimal representation, and it is an example of your irrational number. Now if we are going to see, so we can conclude over here that if the denominator is either 2 or 5 or the multiple of 2 and 5, then such type of cases will be an example of your terminating decimal representation. Over here we can see 1 upon 2, denominator is 2. Here we can see denominator is 5. So whenever your denominator is either 2 or 5 or the multiple of 2 or 5, that means it is in the terms of 2 raised to the power n, 5 raised to the power m. If denominator is in this form, then your division, your decimal representation will always be terminating. That means by simply seeing the rational number, we can come to know whether it is going to terminate or not. Like if I am going to say, your example is 2 upon 30. So 2 upon 30, I am saying the 30, if I am going to split this 30, it will be 2 into 3 into 5. In the denominator, what will come? 2 into 3 into 5. Over here we can see 2 and 5, both is a favorable condition. But over here 3 is even there. That simply means when we will represent it in terms of decimal, it will be non-terminating repeating type of decimal. But if it is your 2 upon say 20, say it is your 3 upon 20. If this is the case, 3 upon 20. So we can see the denominator is 3 upon 20 could be written as 2 into 2 into 5. So in the denominator, it is in the terms of your 2 raised to the power n, 5 raised to the power m. Only 2 and 5 is there in the denominator. So such type of numbers, if we are going to convert it into decimal, it will going to terminate after certain steps, and it will be your terminating type of decimal representation. So simply by seeing the form of P upon Q, we can come to know whether it is going to terminate or it is going to repeat again and again. If your denominator is of the form 2 raised to the power n, 5 raised to the power m, that means in denominator if there is either 2 or 5, multiples of 2 and 5 only, in that case it is going to terminate. And if there is any other number, say if it is coming 2 upon 3 or it is coming 3 upon 7. So in these type of cases, if we are going to represent it in terms of decimal, it is going to non-terminate reoccurring type of decimal representation. So what we can conclude from here, that real numbers are either your rational numbers or it is your irrational number. Rational numbers are the numbers which can be represented in the form of P upon Q. When we will be dividing it or we will convert it into decimal representation, so two conditions are there for rational number. Either it is going to terminate, that means after certain steps your remainder will come to 0, or the second condition will be it is never ever going to terminate, or either a number or a group of number is going to repeat again and again. These two are the condition for the rational numbers. Now, if your denominator means P upon Q form, denominator is in the form of 2 raised to the power n, 5 raised to the power m, in that case your division will be terminating type of decimal representation. Your division will come to an end after certain steps. And if your denominator is not in this form, then the decimal representation will be non-terminating reoccurring type of decimal representation. This is the case for your rational number. Now for the irrational number, decimal representation of irrational number is non-terminating, non-repeating type of decimal representation. That means never ever it is going to terminate. That means because we cannot represent it in the form of P upon Q, so there is no point of division. Simply the decimal representation will be non-terminating, non-repeating type of decimal representation. That means none of the group is repeating again and again. This will be the representation for your irrational number. So by simply seeing the decimal representation, we can come to know that the number is your rational number or irrational number. Just now we have seen that the decimal representation of rational number is either terminating type or it is your non-terminating repeating type. And how to convert rational number into decimals, just now we have seen. Now let's see, if the decimal representation is given, how we can convert it into the form of P upon Q, into the form of your rational numbers. Now the rational number is having two type of decimal representation. So first condition is when your decimal representation or the decimal expansion is your terminating type of expansion, then how we can convert it into the rational number. Now the example could be, suppose I am saying it is your 0.453. This is the decimal expansion of any of the rational number. Now how we can convert it into the rational number? Simply remove the decimal. Over here we can see that there are 3 decimal places. So 1000 will come in the denominator and 453 over 1000, this is the rational number. That means 0.453 could be written as 453 over 1000. Similarly, if your number is 3.75, suppose this is a number. Now how we can represent it? Over here we can see that there are 2 decimal places are there. So what we can do is we can remove this decimal and 100 will come in the denominator. Now if it is divisible, if P and Q both are divisible, we will divide it and we will convert it into simplified form. Like both are divisible by 25. So 25, 4 is 100 and it is your 15. 15 over 4 will be the decimal representation of 3.75. So similarly what we can do is simply we need to remove the decimal, and as many number of decimal places are there, we will keep as many zeros in the denominator. Now one more example I am taking. Suppose it is your 23.12. Suppose this is a number. So again we can see over here that there are 2 decimal places. So it can be represented as 2312 over, because 2 decimal places are there. So 100 will come in the denominator. Again it is divisible by 2. We will divide it and convert it into simplified form. This is how we can represent the decimal expansion is terminating. If decimal expansion is terminating, then we can represent it in the form of your rational number. Now the second condition is when the decimal expansion is non-terminating repeating type of decimal expansion, then how we can convert it into the form of your rational numbers. Now see over here, it is your 0.3 bar. Here only one digit is repeating. So first of all, what we will be doing is we will assume that this 0.3 bar is your x. Value of x is your 0.3 bar. Now because only one number is repeating, we will multiply it by 10. So if this is your equation number 1, and if we will multiply equation number 1 by 10, it will become 10x is equivalent to 3.3 bar. This is your equation number 2. Why it is 3.3 bar? See, it is 0.3 bar. That simply means 0.3333. This is your value of x. Now if we are going to multiply it by 10, it will become 10x is equivalent to 1 3 will come here, 3.3333 ... or we can say 3.3 bar. So if we will multiply this by 10, this will become x multiplied by 10 will become 10x, and 0.3 bar multiplied by 10 will become 3.3 bar. Now if we will subtract these two equations, equation number 2 minus equation number 1. So it will be 10x is equivalent to 3.3 bar and x is equivalent to 0.3 bar. If we will subtract it, this will be your 9x is equivalent to 0.3 bar, 0.3 bar both are going to cancel. It will be your 3 and x will be your 3 upon 9, or we can say x is equivalent to 1 upon 3. That means if the decimal representation is 0.3 bar, its rational number in the form of p upon q, we can write it as 1 upon 3. Similarly, take another example. If it is your 0.45 bar, so what we will be doing in the same procedure, we will assume that x is equivalent to 0.45 bar. This is the value of x. We have to find the value of x only in terms of p upon q. Now if x is this, now over here we can see that two numbers are repeating, 4 and 5. 4, 5 is repeating again and again. So we will multiply this equation by 100. Because two numbers are repeating, so we will multiply it by 100. It will become 100x is equivalent to 45.45 bar. This is your equation number 2. Because we have multiplied it by 100. Similarly, like this, over here we have multiplied it by 10. If we will multiply this 0.45 bar means 0.454545 by 100, it will become 45.45 bar. Now, if we will subtract equation number 2 minus equation number 1. From equation number 2, if we will subtract equation number 1, 100x minus x will become your 99x. And 45.45 bar minus 0.45 bar, 0.45 bar, 0.45 bar is going to cancel. It will be your 45. So value of x will be 45 upon 99. So this is how we can represent 0.45 bar in terms of your p upon q. Similarly, if this is the case, 0.732 bar. Over here, three numbers are repeating. So first of all, what we will be doing, we will assume x is equivalent to 0.732 bar. This is our assumption. First of all, we have taken a value of x is equals to 0.732 bar. Now, because three numbers are repeating, so we will multiply this by 1000. If we will multiply this equation number 1 by 1000, it will become 1000x is equivalent to 732.732 bar. This is your equation number 2. Now, from equation number 2, if we will subtract equation number 1, it will be 1000x minus x, that will be your 999x is equivalent to 732.732 bar minus 0.732 bar, that is your 732, and value of x will be 732 divided by 999. So this is your representation in terms of your rational number. The decimal representation was 0.732 bar, and this can be represented as 732 over 999 in terms of your rational number. So these are the simple cases. Now if the number is your 4.32 bar, over here initially your whole part was 0. In all the three cases your whole part was 0. Now the whole part is your 4. if this is the case, again the same procedure we will be following. We will first of all take x is equivalent to 4.32 bar. Now see over here, again two numbers are repeating. So because two numbers are repeating, we will multiply this by 100. This is your equation number 1. If we will multiply this equation number 1 by 100, this will become 100x is equivalent to 432.32 bar. This is your equation number 2. Because we have multiplied this by 100, so this could even be written as 4.323232 like this. So if we will multiply it by 100, one pair of 32 will come initially, so it will become 432.32 bar like this. Now if we will subtract equation number 1 from equation number 2, so what I could do is I could write this equation number 1 over here beneath it. It will be 4.32 bar. This is equation number 1. Now I will be subtracting it. So 100x minus x will be your 99x. Now 0.32 bar, it is going to cancel. It is 432 over here, whole part, and over in the denominator here, your whole part is 4. So from 432, we will be subtracting your 4. It will become 428. So if we will be subtracting these two, your result will be 428. So value of x will be 428 divided by 99. This will be the representation in terms of your rational number. That means this decimal representation can be written as 428 over 99. Now this one more example we are taking. Now if this is the case that the whole decimal part is not repeating. Over here the whole decimal part was repeating, 0.732 was repeating, 32 was repeating, 45 was repeating. That means whatsoever the decimal part was there, the whole decimal part was repeating. But here is the case when this part is not repeating. So how to solve these type of question? So first of all, see, one of the number is not repeating. First of all, what I will be taking is, we will be assuming x is equivalent to 2.435 bar. Now here we can see that one of the decimal number is not repeating. So first of all, because one number is not repeating, we will multiply this equation number 1 by 10. So this will become 10x is equivalent to 24.35 bar. This is your equation number 2. Because one number was not repeating, so we have multiplied this equation by 10 once. So it has become 10x is equals to, this 4 will come over here. This will become 24.35 bar. Now because two numbers are repeating here, so again we will multiply equation number 2 by 100. Not equation number 1, we will multiply equation number 2 by 100. So this will become 10x multiplied by 100 will become your 1000x. 1000x is equal to 2435.35 bar. This is your equation number 3. What we had done is, because one of the number was not repeating, so first we have multiplied this we had assumed as x, and we have multiplied it by 10. So this has become 10x is equals to 24.35 bar. Now because two numbers are repeating, so what we had done is, again we have multiplied equation number 2 by 100. So this has become 10x multiplied by 100 will become 1000x is equivalent to 2435.35 bar. Now from the equation number 3, we will be subtracting equation number 2. So I am writing equation number 2 beneath the equation number 3, that is your 10x is equivalent to 24.35 bar. This was your equation number 2, and now I am subtracting it. So 1000x minus 10x will become 990x. 0.35 bar are going to cancel. Now from 2435 we need to subtract 24. So 5 minus 4 is 1, 3 minus 2 is 1. It is 2411 and the value of x will be 2411 divided by 990. If it can be further solved, in any case we will be solving it further. We will simplify it, and whatsoever the value will come, that is the representation in terms of your rational number. So this is how we can represent the decimal numbers in terms of your rational numbers. That means if decimal representation is given to us, we can convert it into the form of your P upon Q. Now let's see how to find irrational numbers between any two given numbers. We know that the numbers which cannot be represented in the form of P upon Q, where Q is not equivalent to 0 and P and Q are any integers, are known as irrational numbers. And the decimal representation of irrational numbers are non-terminating, non-repeating type of decimal representation. Now let's see how to find the irrational number between any two given numbers. Now the first condition is when any two numbers are given to us, any two positive rational numbers are given to us, say A and B are any two positive rational number, such that product of these two numbers is not a perfect square. If the product of these two numbers is not a perfect square, in that case root of AB will be a rational number between A and B. That means if A and B, there are two numbers are there such that they are positive numbers, positive rational numbers are there, and if we have to find a irrational number between these two and the product of these two, that means A multiplied by B is not a perfect square, in that case root of AB will be a irrational number between these two given numbers. Suppose I am saying that A is your, one of the number is your 2 and another number is your 9. If one of the number is 2 and another number is 9, we have to find a irrational number between these two number. Then product of these two, that is 2 multiplied by 9, 9 2s are 18 and 18 is not a perfect square. That simply means root of 18 will be a irrational number between these two given numbers. This is one of the method. Now the another condition is when two decimal representations are given to us. Two numbers are given in its decimal representation. Then how to find an irrational number between these two numbers? We know that the decimal representation of an irrational number is non-terminating, non-repeating type of decimal representation. Here we can see that this number is greater than this number. Now we have to select a number, decimal representation of any of the number, which is greater than this and should be smaller than this. So we can take any number of our choice which is greater than this and smaller than this, and its decimal representation should be non-terminating, non-repeating type of decimal representation. So see over here, this is a terminating number because dots are not written. So it is a terminating number and it is a non-terminating repeating. It is not even repeating, it is your non-terminating, non-reoccurring type of decimal representation. So number which is greater than this could be your 0.111. This is greater than this number but should be smaller than this number also. So over here we can take now 0, 5, 7, any number of our choice, 8, 5, ... And number should not be repeating, so take 3, 2 like this. And this is a number which is non-terminating, non-repeating type of number. That means it is an irrational number and this number is greater than this number and lesser than this number. So anyhow we can write any number of our choice. Now third condition is if numbers are given in terms of your P upon Q. In this form if it is given, so what we will be doing is first of all we will convert this form into your decimal representation. So 1 upon 4 could be written as 0.25 and 3 upon 2 could be written as 1.5. If we will divide these, we can come to know that 1 upon 5 could be written as 0.25 and 3 upon 2 could be written as 1.5. Now we are having the decimal representation of these numbers. Now we have to write any irrational number which is greater than 0.25 and less than 1.5. And decimal representation, as we know, it will be non-terminating, non-repeating type of decimal representation for the irrational number. So we can take it as 0.5789237653 ... So this is a number which is non-terminating, non-repeating type of decimal representation. So it is an irrational number. We can take any number between this and this, and any such number will be your irrational number between any two given numbers. So this is how we can find any irrational number between any two given numbers. If it is decimal representation, then we can find. If it is in terms of P upon Q, then we can find. If it is like this, then also we can find an irrational number between any two given numbers. Now let's see how to represent real numbers on the number line. The real numbers are represented on the number line by the process of successive magnification. Because we are magnifying the numbers between any two given numbers, that's the reason this process is known as process of successive magnification. Now the conditions are, first condition we are taking when the number is terminating type of decimal representation. Suppose I am saying the number is your 2.75. This is the number which is a terminating type of number. We have to represent this on the number line. So from here we can see the whole part is 2. That means this number will lie between 2 and 3. What we will be doing is, first of all, we'll make a line, number line. Here in the center we have taken 0. In the left hand side we have taken the negative numbers. In the right hand side we have taken positive numbers at the unit distance. Now we know that the number is between your 2 and 3 because it is 2.75. That means number will lie somewhere between 2 and 3. So we will magnify the distance between 2 and 3. What we will be doing is, now we will be focusing only between the numbers 2 and 3. We will divide it into 10 equal parts. So 1 part, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal parts we have divided. So first part will be your 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, 2.9 and this is 3. Now we can see over here that this will lie between 2.7 and 2.8. That means we have to magnify this 2.7 and 2.8 further. What we will be doing is, again we will make a number line. Here we will be writing 2.7. Here we will be writing 2.8. And then further we will divide it into 10 equal parts. So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 equal parts. So first part will be 2.71, 2.72, 2.73. Like this we will number it the whole 2.76, 2.77, 2.78, 2.79 and 2.8. We have to represent 2.75. So here this point is your 2.75. This is suppose your A. So this A point represent your 2.75. So in the case of your terminating type of numbers, we can exactly locate the point. That is your 2.75 we have located. This is how we will be representing the numbers on the number line. Now the number, if the number is your non-terminating repeating type of numbers. Suppose I am saying your number is 3.3 bar. That means 3 is repeating again and again. So it could even be written as your 3.3333 ... This is the number which we have to represent on the number line. So here we can see that the number will lie between 3 and 4. It is greater than 3 but less than 4. So first of all we will make a number line. In the center we will take 0. In the left hand side negative numbers. In the right hand side we will take the positive numbers. Now the number will lie between 3 and 4. So we will further magnify 3 and 4. So now the next number line will be taking, at the one end we will be taking 3, at the other end we will take 4. Now further we will divide it into 10 equal parts. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. First point will be your 3.1, 3.2, 3.3, 3.4. Like that we will number it. 3.7, 3.8, 3.9. Like this. Now we can see the number will lie between 3.3 and 3.4. Further we will be magnifying it. At one end we will be taking 3.3. At the other end we will be taking 3.4. Further we will divide it into 10 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. First part will be 3.31, 3.32, 3.33. Like this we will keep on writing. 3.5, 3.36, 3.37, 3.38, 3.39. Now we can see that the number will lie between 3.33 and 3.34. Further we will be magnifying these. At one end we will be writing 3.33. Another end we will be writing 3.34. Now again we will be dividing it into 10 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. It should be 10 equal parts. Randomly I have marked. So it's not equal but it should be equal. First part will be 3.331, 3.332, 3.333, 3.334. Like this we'll be marking. 3.337, 3.338, 3.339. Now see, we can see over here that this point will lie between 3.333 and 3.334. So it's not exactly this point, it's not exactly this point, it will be somewhere here. So we won't make a point directly like this we had done. It will be something like this arrow, that the point will lie somewhere here. This is how we will be representing the number, that is 3.3 bar. This will be something like this, some arrow, because it is not exactly this point. It will lie somewhere in between these two, and that too it will be towards 3.333. That's why somewhere here we have marked an arrow, that this point will be represented somewhere here. This is how these are represented. If your real numbers are given, we can represent it in on your number line. So till now what we have learned is, we have learned what number system is, what types of numbers are, what rational number is, what irrational number is, what is their decimal representation, how we can convert it into decimal, and if it is given in decimal, how we can represent it in the form of P upon Q, how we can represent all this on the number line. So in the next video, we'll be continuing with the same chapter. Thank you.